Okay, we are in section 3-4. We're doing part 2. So we just have example 4 and 5 to get through. And these are the harder ones, the word problems. So I need you to slow down and make sure you understand the material. Okay, write things down if you need to, but you can pause and rewind whenever you need to. So example 4, a skydiver made jumps with 3 parachutes. The graph shows the height of the skydiver from the time the parachute opened to the time of the landing for each jump. Okay, so guy jumps out of a plane, then he opens his chute, and the graph shows the height of the skydiver from time he opens his chute to the time of the landing. All right, so statement A, the parachute opened at the same height in jumps A and B. A and B. Okay, the height. The height for B was over 4,000. The height for A was less than 4,000, so that is definitely not true. The parachute was open for the same amount of time in jumps B and C. So I have B and C. The time for B was less than 4 minutes. The time for C was greater than 5 minutes. So that is definitely not true. The skydiver descended at the same rate in jumps A and B. So in jump A, okay, we have this slope. So we could calculate it by picking some points, but he started at a shorter height and still landed in the same time. So that's not the same rate as jump B, which was a higher height at the same time. So I would say the rate of the jumper in B was faster than the rate in A. It's a steeper slope, so that means that it would be faster. So that is not true. The skydiver descended at the same rates in jump A and C. So let's just talk through it. I have jump A, which is right here, and jump C. Okay, visually they look to be parallel, so visually they look to be the same rate, but we're going to actually calculate it in a minute. So I believe this one is true, but we need evidence for true. You can't just circle it and expect it to be okay. Okay, we're going to calculate it. Evidence for our true statement. And actually, we are not doing evidence. I just went back and looked to make sure I was teaching you everything that I needed to teach you. And visually, it is the same rate because it looks like it. That's one of the joys of multiple choice, right? Because it looks like parallel. Okay, then they're the same rate. Awesome, right? All right, you try. Line N passes through those 2 points. Line M passes through those 2 points. Is N perpendicular to M? Okay, this is example 3, which we did in the last video. If you remember, perpendicular lines have opposite, which if it's positive, it goes negative. If it's negative, it goes positive, and reciprocal slopes. And then in example 4, which parachute is in the air for the longest time? Explain. So push pause and try those. Okay, there are the answers for number 4 and 5. Last you try. Go ahead and push pause. X-intercept in this example, or in example 4, represents how many minutes the parachuters are in the air. How can you use this to eliminate one of the choices? That was the multiple choice question. Okay, the multiple choice question said, the skydiver made jumps with 3 parachutes. The graph shows the height of the skydiver from the time the parachute opened to the time of the landing of each jump. Which statement is true? So, to eliminate one of the choices, you would just say B and C are in the air. Different amounts of time. Okay, we use that information to eliminate some of the choices. All right, example 5, solving a real-world problem. During the climb on the Magnum XL 200 roller coaster, you move 41 feet upward for every 80 feet you move horizontally. At the crest of the hill, you have moved 400 feet forward. Okay? So you move 41 feet upward for every 80 feet you move horizontally. At the crest of the hill, you have moved 400 feet forward. So I think that would be 400. We're going to make that a straight line because it just makes it. So that would be 400. And your slope is rise over run. Okay, that's the data we're given. Making a table. Make a table showing the height of the Magnum at every 80 feet it moves horizontally. How high is the roller coaster at the top of its climb? Okay, part B. Write a fraction that represents the height of the Magnum, the height the Magnum climbs for each foot it moves horizontally. What does the numerator represent? Part C. Using a graph. Another roller coaster, the Millennium Force, climbs at a slope of 1. At its crest, the horizontal distance from its starting point is 310 feet. Compare this climb to that of the Magnum. Which climb is steeper? So we would go up 1 over 1, up 1 over 1, up 1 over 1. Okay? So I believe with a slope of 1, up 1 over 1, up 1 over 1, at 310 horizontal, our height would also be 310. And I know that's hard to see. Okay, but that would be a slope of 1 over 1. All right, so let's give us some space to... So let's do part A here. Okay, I need a table. And I'm going to try to make my table as neat as possible because it's easy for the teacher to read things when things are neat. Horizontal distance and height. So, horizontal distance, remember we move 41 feet up for every 80 feet we move forward. And then we're at 82 feet, 160. And then we do 123 feet, just adding 80 on, add 41 on, 164 feet, add 80, 320. And I'm left way too much space because the last one is 400 feet and I'm at 205. So I got 400 feet forward, 205 feet up. So the Magnum XL 200 is 205 feet high at the top of its climb. Cool. Let's go back a little bit. So now we're going to do part B. Okay, we have... Okay, this fraction represents our slope. So rise over run. So every 41 feet it goes up. It goes 80 horizontally. So if I simplify this, I get, just do 41 divided by 80. Okay, so this is our slope in decimal form, which is much more useful in the real world. Okay, so that's our slope of the Magnum XL 200. Forward one. All right. So this shows you what we're doing here. Okay, the Magnum, if you remember, we went 205 feet that way and 400 feet up. Okay, our slope for the Magnum was 0.5, I forgot, there we are, 5125 over 1. And the slope for the millennium, spelled that wrong, is 1 over 1. Okay? So we know that our slope for the millennium force is steeper than the slope for the magnum. Okay? The slope for the millennium force is 1, which is greater than the slope for the magnum, which is 0.5125. So you know that the millennium force has a steeper climb. It doesn't necessarily go up higher. Yes, it does. I'm sorry. I knew I wasn't saying that right. Okay. That's your horizontal distance. This is your vertical distance. Horizontal, vertical. So the millennium force goes higher, which some people think is a cooler roller coaster. Okay, this one is not quite as high. All right, you try. Line Q passes through those 2 points. Line T passes through those 2 points. Which line is steeper, Q or T? So you need to calculate the slope and figure out which slope is steeper. So I calculated the slope for both. I turned them into decimals just to help out. You certainly don't have to. This is the steeper line because it's greater than 1, so line Q is steeper. You try again. What if, suppose a roller coaster climbed 300 feet up for every 350 feet it moved horizontally? I'm going to give you some help here. Rise over run. Is it more steep or less steep than the magnum? If you remember, the magnum had a slope of 0.5125. So tell me if this new roller coaster is more steep. Push pause and try it on your own. Okay, if you remember, the slope of the magnum was 0.5125. The slope of the millennium force was 1. So this is more steep than the magnum and less steep, can't write, than the millennium force. Alright, push pause, I'll put in some answers. There you go, good work today.